Now let's take a look at the difference between three terms that you may hear thrown around called unicast, multicast, and broadcast. Now we're going to break each of these three different terms down by dividing them between IPv4 and IPv6 because it's a little bit different when we're referring to them. Now unicast, multicast, and broadcast, or also anycast for IPv6, refers to the ways that our individual computer, our individual device, is going to try to talk to other device or devices out on the network. So we need to understand how these work and understand what they're referring to. Now when we're referring to a unicast, we're referring to, when we're talking about IPv4, we're talking about a one-to-one relationship. So a unicast will be a single computer or a single node talking to another single computer or single node. So a unicast, we're sending a packet to a unicast, when we're sending to a unicast address. A unicast address is an address that specifies one single computer or one single node. In IPv6, this includes our addresses which are known as link local, site local, unique local, and global unicast. All of these are unicast addresses that specify one single interface on a network or around the world, especially when it comes to our global unicast. Our global unicast refers to one address, one IPv6 address on the entire Earth and the entire world. So that's going to be our unicast, where it's a one-to-one relationship. Next we have our multicast. Now our multicast is going to be one-to-many. In the case of an IPv4 address, we have multicast addresses, where we'll be sending to a specific multicast address that different nodes or computers are members of. And when we send to this multicast address, it actually sends to those multiple nodes. This may be useful when we're trying to send or load balance on a server and we're trying to see who will respond to us first, or just trying to send to a group of computers that are part of this multicast group. So with IPv4, a multicast address will be one-to-many. The same with IPv6. It's one-to-many. Now IPv6 does not have broadcast. It does not have one to everybody. It doesn't have that broadcast mentality, but it does have multicast groups which are sort of used to which are used in place of using broadcast. And IPv6 replaces broadcast with a combination of multicast and anycast addresses. Anycast, which we'll talk about in just a second. So remember, unicast is uni, which is one-to-one, like unicycle with the one wheel. And multicast is multi, so we have many, one-to-many. And then we have broadcast and anycast. Now broadcast is IPv4 and anycast is IPv6. Broadcast is going to be one to anybody who will listen and is in my same broadcast domain. So what's a broadcast domain? Well, a broadcast domain is essentially any computer that you could hypothetically reach by just talking with their MAC address. So you are reaching these computers that are inside of your router or inside of your network. Now, these broadcast addresses, if we had a network diagram here, where if we have, we'll give ourselves a standard switch, we're going to start using these icons more. For example, this box has two arrows going in opposite directions for a switch. So we have our switch with our different computers on it, connected to another switch with other computers on it, and then our second switch is connected to a router. If on the outside of this router, say there's another switch with more computers, and our computer right here sends out a broadcast message with IPv4, our broadcast message only propagates on this side of our router. Our broadcast domain is this segment right here that's connected by our switches here. So when we send out a broadcast, we'll only be hitting these computers here, as well as our router. It's also important. So these computers here and our router here. Computers, switches, router, but our router will not propagate our broadcast message. Just imagine the horror that would occur on the internet if routers did broadcast or propagate broadcast messages. A single computer anywhere connected to the internet could send out a broadcast message and it would propagate all over the world if every single router potentially propagated out these broadcast messages and there was no rules or anything to stop them. Every single router would just continually broadcast messages all over the world. So we needed to have a location somewhere where we said, hey, this device is not going to propagate broadcast messages, it's not going to route broadcast messages, and so that is at our router. So our broadcast is going to send a message to everyone in our broadcast domain or everyone on our network inside of our router. Our router will not broadcast or will not route broadcast messages. Next we have IPv6 Unicast. Now Unicast is a bit different than broadcast because Unicast is going to be one to the nearest anybody. So our IPv6 and then to our switch and then to another switch with a computer over here and then a computer over here off our first switch. Send out an Unicast packet, and our closest computer to respond would be our computer on our first switch here. So our Unicast is going to be one to nearest. So IPv6, rather than having broadcast built in, is going to use a combination. We're going to use a combination of multicast and Unicast to essentially achieve what we needed broadcast for in IPv4. So that's our difference between our multicast, unicast, and broadcast, or also our Unicast. And remember, our prefixes help us a lot. Unicast, uni, one-to-one. Multicast, multi, one to multiple, many. Broadcast, we're sending to a broad amount of people. We're going to send to as many people as we can in our broadcast domain. And then Unicast, one to whoever's the closest. With broadcast and Unicast, however, remember that broadcast is IPv4 only and Unicast is IPv6 only. So thank you for joining us here today on cybrary.it. We talked about a lot of different topics here in 1.3. We talked about IPv4, IPv6, how IPv4 and IPv6 are made up of different bits and how they all work together to form the 32-bit address scheme in IPv4 or the 128-bit address scheme that we have in IPv6. We talked about everything from subnetting to MAC addresses to how to do subnetting by breaking off into our little bits, and private and public addressing and our different addressing classes. So it was a very hefty module and there's a lot of information to go over and review in it and to study and get very good at it. But when in the world of networking and in the world of Net Plus, IPv4 and IPv6 and our MAC addresses and all of the different properties of IP addressing are very, very important because it's how we talk in today's day and age of the internet. IPv4 is king. So it's a very important module. It's very important to go in depth and to understand it very well. And hopefully it was very informative for you. And hopefully we'll see you here next time on cybrary.it.